So this section is really going to kind of tie everything in together, and it's going to use all of the stuff we've learned so far to try to solve problems. And so there isn't a set strategy because every problem is going to be so different from one another, but there's kind of an understanding of things that you need to do within a problem. So the first thing you always want to ask yourself when you're reading a question is, what is the thing you're actually searching for? What is your end goal that you want to answer? You also want to figure out what's a known quantity and what's unknown. So there's going to be things that are fixed, but there's going to be things that could vary, and it could be multiple components that vary. From there, you want to try some kind of plan. So maybe draw a picture, label different things if it makes sense to draw a picture, write things out in words, label the things, or give numbers to stuff that is set. If something is unknown, we're going to go ahead and assign a variable to it. Now, the thing is, you have to be careful because you don't want to assign multiple variables because your whole goal is to find one quantity in the end. So it might be something that you have to write one piece in terms of another, and we'll see quite a few examples like that later on. So once you have that picture or that words describing what's going on, you're then going to find some type of relationship between everything. So whether it's setting up a perimeter, whether it's setting up an area formula, any of these given pieces. Once you set up this equation, which is that relationship, you want to go ahead and find the unknown for that equation. And then the thing you want to ask yourself at the end, it's not really a way to check that this is the right answer because you're the one that's setting everything up, but more so asking yourself, is this reasonable? These are real life problems. It should make sense in the context of it. So if you're finding out that it's a negative side length, a negative volume, negative time to do something, that doesn't make sense at all. So that's indicating that you made some kind of mistake either in solving the problem or setting it up. So although it's not helpful, it still gives you that idea that, okay, what I did was not right. I need to come up with something new, okay? So we're just going to try a ton of different examples, and we'll try to figure out what we can do for each of them. So in the very first problem, Jack and Diane are going to start saving for retirement. They deposit $100 in the account to start out. They then plan to deposit $50 per month. We want to figure out how many months is it going to take them to reach $4,500 in their account. So if you remember anything about this, this is that linear relationship because we're adding the $50 to this account every single month. But again, I'm going to break this down into words. So a picture doesn't make sense, but I can think about this in words instead. So if I consider the total in my account, it's always equal to the initial deposit you have when you set up the account, plus however much you add every single month. And in this case, because we're doing this for multiple months, we have two things going on. So what we're doing is making a deposit every month for some unknown number of months. Okay. Just think you have 100 in your account. After 1 month, you've added 50. After 2 months, you've added 50 times 2. After 3 months, you've added 50 times 3. So the thing that's unknown in this equation is how many months we're leaving money, or how many months we're putting money into this account for. So this is our unknown quantity that I want to assign a variable to. You can use whatever you want, but it makes sense to use a letter that works for the problem. So in this case, I'm going to call the number of months M. That is my unknown, okay? These other pieces are all known. I know the total in the account, I know the initial deposit, and I know how much I'm depositing in every single month. So these are all fixed numbers. So I'm looking for there to be $4,500 in the account. Our initial deposit is $100, and then we're depositing $50 per month for N months, okay? And what I need to do now is I need to solve for m. Okay. So using our tools, I've got to isolate the variable. So I need to move this constant to the other side to get the thing involving m on its own. So these two are going to cancel. And then 4,500 minus 100 is $4,400. And on the right-hand side, we have 50m. Then very last step, to get m on its own, we go ahead and divide both sides by 50. That will make these two cancel out. And if you plug 4,400 divided by 50 in your calculator, you're going to see 88 is equal to this variable m. So it's going to take 88 months. To reach $4,500. Okay. And that seems reasonable. You could figure out how many years it was. It should not take you like 1,000 months to do that. That would be an indication that maybe I divided something wrong or typed something wrong into my calculator. Okay. For these next couple ones, we're going to be working with area formulas. So we are told the area of a rectangular garden is 7,254 meters squared. If the width of the garden is 78, we want to figure out what is the length. So here it makes sense to draw a picture. So we've got a rectangular garden going on. Let's see if it'll make it into a nice rectangle. No, that's all right. So we don't know the length, so I'm going to call one side of this L. But we do know the width is going to be 78 meters. So no need to assign a variable to this because it's given a fixed amount. And then I do know that the area of this rectangle is 7,254 meters squared. Okay. So thinking about how we find the area of a rectangle, that's going to be the length times the width. Okay. And again, filling in the pieces, we know the area, we know the width. This is the thing that's unknown we're searching for. So filling in our constants, the area is 7,254. The length is what we're calling L, and the width is 78. Okay. You can fill in the units if you want to, but again, it's a length at the end. We know it should be in meters. So solving for L, since we're multiplying these two, we're going to divide both sides by 78. And that will make these two disappear. And then if you go through and do 7,254 divided by 78, you're going to see 93 is equal to L. And again, because this is a word problem and this is something that's realistic, we should have the units attached to this. So the length is going to be 93 meters. Okay. For the next one, similar idea that we're working with a rectangular window, but now we're told the perimeter is going to be 330 centimeters. If we know the length of the window is 94, we want to figure out what is the width. So again, going to draw a little picture to help me out, and that time it did turn to a nice square. I have no idea what the width is. That's my goal. So I'm going to call these sides W. We want to figure out what does this equal. But we do know that length is going to be 94 centimeters. And again, I'm not going to worry about the units so much. I know at the end, because this is the width, it should just be my units. So it should be in centimeters. And then they tell us the perimeter is going to be 330 centimeters. Okay. So remember, perimeter is the distance that we would walk around this object. So our perimeter is going to be one side plus the other, plus this bottom side, plus the other. So that's starting here, going all the way around. We just add all of those side lengths together. Okay. And now our goal is to figure out what is W equal to. Okay? But as you can see right now, I have two variables going on. I've got P and then I've got W. So I do have one thing I want to fill in. We do know the perimeter is 330. Okay. And then on the right-hand side, I'm going to group stuff now just to make sense or make my life a little bit easier. We can go ahead and add the two constants together. 94 plus 94 is 188. And then if we add W plus W, that's going to give us two W's. So going through and solving for W, we've got to isolate it. So that means we need to move this to the other side by subtraction because it's positive here. So that's going to make these two disappear. And then 330 minus 188 is going to leave us with 142. And then we're left with 2W on the right. And then finally, to just solve for W, which is our whole goal, we go ahead and divide by 2 to make those cancel each other out. So 142 divided by 2 gives us 71. And that is going to be our width with the units of centimeters. Okay. Now let's try something completely different. We're told a garden table and a bench cost $750 combined. The cost of the garden table is 2 times the cost of the bench. We want to figure out what is the cost of the bench. So unfortunately here we have a bunch of unknowns. We have no idea how much the table is, nor do we know how much the bench is. However, these are the two things that I bought. So in words, my total cost is going to be the cost of the bench plus the cost of the table. Okay. Now this I know. The problem is I don't know either of these two things. However, this is the one that I'm searching for. Okay. So what I'm going to do is I'm going to assign a variable to this quantity because it's what I want to solve in the end. What is the cost of the bench? So I'm going to call this B. Makes the most sense. Okay. I do know my total cost. It's $750. Okay. And I don't know the cost of the table. However, they do give us this piece of information that the table is 2 times the cost of the bench. So if my bench is $B, my cost of the table is going to be 2 times this variable B. So you can think of it, if your bench is $100, then your table is 2 times 100 or $200. If your table is $300, or your bench is $300, then the cost of the table is 2 times 300 or $600. So we're able to write an equation solely involving this variable B. I don't have to assign a different variable T to this. Everything is in terms of the cost of the bench. And then from here, it's a matter of just solving for B. So I can't do anything on the left, but on the right, we have B plus 2B. So that leaves us with 3B. And then to solve for B, we just go ahead and divide by 3, since we're multiplying the 3 and the B. So those cancel each other out. 750 divided by 3 is $250. And that's exactly this quantity B. So the cost of the bench is $250. Okay. All right. This next one is definitely going to be the hardest of all of our problems. So we're going to take this as slow as we possibly can, but there's a lot of components going on to it. So we're told at the movie theater, child admission is $5.30 and adult admission is $8.90. Last Monday, 126 tickets were sold, and there was a total sales of $941.40. We want to figure out how many kid tickets were sold. Okay, so this is a problem because I have 2 unknowns. I don't know how many kid tickets were sold, and I don't know how many adult tickets were sold. But what I need to do is I need to somehow relate the number of tickets plus the cost per ticket to get this total sales amount. So again, I'm going to start by breaking this into words first. So if you think about the total sales for this movie theater, it's going to equal the sales from the kids' tickets plus the sales from the adult tickets. And then we can break the sales down into an even more precise scale. So each kid's ticket costs $5.30, and we're multiplying it by however many kid tickets we sold to get the sales from that. So really, I can take this a step further and say my total sales is going to be broken down as the price per kid ticket multiplied by the number of kid tickets we sell. And then likewise, the sales from the adult tickets, it's the cost per adult ticket multiplied by the number of adult tickets sold. So kind of going through and seeing what's known and unknown, we know the total sales, we know the price per kid ticket, and we know the price per adult ticket. However, these two quantities, the number of kid tickets and the number of adults, are both unknown. Okay. So there's one piece of information that I haven't used yet. So kind of going in here, we know the price per kid ticket, we know the price of adults, and then we also know this total sales. So we've used these three pieces of information. The thing we haven't used yet is that there were 120 tickets sold. So what I want to do, because in the end, I want to figure out how many kid tickets were sold, I'm going to assign this the variable K. You can use C as well, but I just wrote kid because it's easier than writing out child. Okay. So I'm going to let K be the number of kid tickets. It's very hard to guess and check. Yes, you can do it. But if there were like 1,000 tickets sold, it's not so easy to figure out or split things up and try to see if things work. So setting up this equation is going to be much easier for us. Okay. So if I can come up with some kind of expression for the number of adult tickets involving K, then I can set up this equation. So if you think about it, not in a formula form, if I say that we sold 6 kid tickets, that would mean that there would have to be 120 adult tickets sold because the two need to add up to 126. If I sold 100 kid tickets, well, that means there's 26 left over. That's how many adult tickets there were. So what I'm going to do actually is say then that the number of adult tickets is going to be the total number of tickets minus how many kid tickets we sold. So really, we can use the equation or expression 126 minus K to represent the number of adult tickets. And again, just to make sense of this formula, if I sold 6 kid tickets, that tells me the number of adults is 126 minus 6. If I sold 100 kid tickets, 126 minus 100 leaves 26 left over for the adults. So this is where that piece of information is getting used. Okay. So I have everything I need now to set up this equation because this is my last unknown. We're going to use the expression 126 minus k. So from here, we can go and create our equation. Our total sales is $941.40. The price per kid ticket is $5.30. The number of kid tickets is K. The price per adult ticket is $8.90. And then I need to multiply that by this whole expression, which is the number of adult tickets, 126 minus K. So that's left me now with a single equation involving this variable K that I want to now solve for. So again, I've got to isolate the value of K, but the problem is I've got it in a few instances. So to be able to get rid of these parentheses and move stuff around, I'm going to go ahead and distribute the 890 out. So we're doing absolutely nothing over here. And then if you distribute this out, you'll have to do 8.90 times 126 minus 8.90 times K. Okay. And then before I start combining stuff, I'm going to go ahead and do that multiplication. But if you feel confident skipping steps, absolutely. So if you multiply the two of these together, you should get $1,121.40. Now it's a little bit nicer. We have a couple instances of K. We've got 5.30 minus 8.90. So if I go ahead and group those together, which is just subtracting the first two numbers, 5.30 minus 8.90 gives you negative 3.6. And then to get the K's on its own, I've got to move this to the other side. And because it's positive, we're going to go ahead and subtract it from both sides. So this way those two cancel. And now I need a little bit more room, so I'm going to go up here. If you do 941.4 minus $1,121.40, it leaves you with negative 180. And that's equal to negative 3.6K. And then one last step, we've got to divide by negative 3.6. And so if you take a negative times or divide it by a negative, it ends up turning positive, which is great because this should be a positive number. We end up with 50 equals K. So we sold 50 kids tickets. And then if there was a part B to this asking how many adult tickets there were, you would do 126 minus 50. You had 76 adult tickets. Okay. So definitely a very hard problem. So you'll see some of them are a little bit more complex than others. These last couple ones only took a couple steps, but this was a lot more intricate, and that's okay. Just do your best with these. Try as much out as you can before you try any type of help me solve this feature. Okay. So let's just try a couple more different ones. This next one, we're going to go back to geometry. So we're told a farmer wants to build a rectangular pen to house some goats. They want the length to be twice the width. If they have 309 feet of fencing, we want to figure out how wide is the pen going to be. So again, going to draw a picture just to make life a little bit nicer. So I don't know what the width or the length are, but my goal is to figure out how wide is this pen going to be. So I'm going to label two sides with W and try to make an equation just involving W. I don't know the length either, but they do give me this piece of information that the length is going to be twice the width. So what I can do is I really can say this side is 2 times the width. Okay. So I have all sides of my rectangle in terms of W. Now I still need to set up some kind of equation, and so the only numerical thing I haven't used yet is this 309 feet. So if this is how much fencing they have, that's representing the perimeter. So the perimeter for this is going to be 309. Okay. So I can set up an equation. If I add all 4 of these sides together, it should end up equaling 309. So starting with the top side, that's 2W. The right is W. The bottom is also 2W. And the left side is W. So if we add up all of those, we've got 2 plus 1 makes 3W, plus another 2 is 5, plus another W leaves us with 6W on the right-hand side. And then to get W on its own, we go ahead and divide by 6 to make these two cancel. And if you do 309 divided by 6 gives us 51.5. And our units on this, because the perimeter was given in feet, mean the width is 51.5 feet. Okay. Let's try another one now. Ashley received a $70 gift card for a coffee store. She used it in buying some coffee that cost $8.52 per pound. After buying the coffee, she had $18.88 left on her gift card. We want to figure out how much coffee did she buy. And I'm actually going to do this 2 ways so I can show you that you don't need to set up an equation to solve this particular one. Again, with quite a few of these, you don't have to set up an equation, but it just makes it very nice and a lot easier when you start getting more complicated situations. So if we think about this, she had a $70 gift card and she's got $18.88 left on it. So if I want to think of the amount she spent, I'm going to take the total price of the gift card and I'm going to subtract what's left. So she ended up spending $51.12 on coffee. So this is how much she spent, and it costs $8.52 per pound. All I need to do is divide the two to figure out the number of bags of coffee. So the number of bags she bought, or the number of pounds, is going to be the amount she spent divided by how much it was for each pound. So if you do $51.12 divided by $8.52, you end up with exactly 6. So she ended up with 6 pounds of coffee. Okay. So again, absolutely not necessary to set up an equation. I'm going to show you what that equation would be though, so you can see it. If we break this into words, the gift card amount is going to be the amount she spent plus the amount remaining. And then the amount she spent is dependent upon how many pounds she bought. So the amount she spent is the price per pound multiplied by the number of pounds plus this amount remaining on the gift card. Okay. So our $70 is equal to the price per pound, which is 8.52, multiplied by the number of pounds. I'll just call this X because L kind of looks like a 1 a lot of times. and then the amount remaining on the gift card is $18.88. So you would end up solving this honestly in exactly the same way. To get the unknown on its own, you'd subtract 1888, which is exactly what we did. So if you do 70 minus 18.88, it leaves you with 51.12. And then we've got the 8.52x. So to get x on its own, we divide by 8.52. So exactly the same steps. Okay. So you still end up with 6 pounds of coffee as your unknown variable. All right, so completely up to you what you want, but again, setting up this equation is going to be the more precise approach when we're dealing with complicated numbers or we have a lot of pieces going on. Because back up here, if you were to try to do this without setting up an equation, you're going to have a very hard time figuring it out. Guess and check is not going to work. So let's try one more. We're told 3 consecutive integers have a sum of 48. We want to find those specific integers. And all that means when we say consecutive is it's one after the other. Integers are our nice counting numbers. So these are numbers like 5, 6, 7, or 10, 11, 12. They're one after the other. Okay. So when I add all of these together, it better equal 48. There is kind of a trick to these because you're adding up 3 integers. If you take 48 and divide it by 3, it's actually going to give you one of them. So then you can kind of mess around from there. But I'm going to show you the more precise way again because it's helpful in a lot more situations. I have no idea what any of these integers are. But let's say the first integer is x. Then the second integer is one more after that. So all I do is add 1 to the previous one. And then my third integer is I take this one and I add another 1 to it. So it's 2 more than the original. So you can see just based off these, they fit the pattern. If x is 10, then my next number is 10 plus 1 or 11, or 10 plus 2, which is 12. So it's giving you those 3 consecutive integers. And then when I add all of these together, it better equal 48. Okay. So combining those like pieces, x, x, x gives us 3 x's. And then 1 plus 2 gives us a plus 3. So solving for x gives us the first integer, which I can then use to find all of the others. So to get x on its own, we go ahead and subtract 3. And that gives us 3x is equal to 45. And then we go ahead and divide by 3 to give us that the first value or the first integer is 15. Okay. So listing out my integers, go back up here. My first number is 15, which means my second integer is 16, and my third integer is 17. Okay. So these are the 3 integers that add up to 48. Okay. And again, if you take 48 and divide it by 3, it gives you 16. So it actually gives you this middle one. And then you just have to figure out, okay, is it 14, 15, 16? Is it 16, 17, 18? You'd have to go from there. So a little bit of an easier way, but again, completely up to you what you want to do. So take your time with these, try your best. Try these out before you immediately jump into the help me solve this feature, because otherwise you're never going to get good at being able to do these on your own, like in testing situations.